You know, when we picture these huge, high-tech projects like massive LED screen installations, our minds usually jump to that final, brilliant result. But what about behind the scenes? In those service tunnels and maintenance shafts, that's where a hidden and frankly often underestimated danger lies: confined spaces. Today, we're going to unpack the blueprint for staying safe in these absolutely critical environments.
The quote on this slide really says it all, doesn't it? Loss of consciousness, impairment, injury, or death. Let's be clear, we are not talking about minor risks here. In a confined space, the environment itself can become a fatal threat in just a matter of seconds. So let's break down exactly how to manage that threat. All right, here's our roadmap for this explainer. We're going to start by identifying these invisible dangers, then we'll define what actually makes a space confined. After that, we'll look at the official safety blueprint, walk through the step-by-step entry protocol, and wrap things up with the all-important rescue-ready mindset.
Okay, first up, where are these hazards actually hiding? You might be surprised. They are pretty much all around us, especially in these complex, large-scale installations. They are the spaces behind the spectacle.
I mean, think about the last stadium or arena you were in. Behind that gigantic video wall, there's a maintenance shaft. Under the floorboards, you've got service pits for all the power and cabling. Those huge outdoor screens, they have weather enclosures. Even the temporary control racks set up for a concert can create a confined space. They're a core part of the infrastructure, which is exactly why we have to know how to spot them.
So, what officially turns just a tight spot into a potentially life-threatening confined space? Well, it's not just about being small. There's a formal definition that helps us understand and, more importantly, mitigate the very specific risks involved.
And here it is. The key phrases you need to burn into your brain are "not designed for human occupancy" and "poses a health and safety risk." Look, this isn't an office or a hallway we're talking about. It's a space built for equipment or infrastructure, and the moment a person steps inside, they're entering an environment with inherent, built-in dangers.
This really boils it all down to a simple three-point check. If you can answer yes to all three of these, it's not meant for people, getting in and out is tough, and there are hazards inside, then you absolutely must treat it as a confined space. No gray area here.
Thankfully, managing these risks isn't just guesswork. There are well-established national standards that give us a clear blueprint for safety, and following these isn't optional. It's really the foundation of any professional, safe operation.
Okay, two of the big ones you need to know are ANSI Z117.1 and A1033. The easiest way to think about it is this. Z117.1 is the micro-level playbook. It's for the confined space itself, the what to do when you're there. A1033 is the macro-level framework for the entire construction project, making sure everyone in every company is coordinated. They have to work together.
The most important takeaway from these standards is that they demand preparation. This is not about making it up as you go on site. It's about having a formal, written program, a thorough hazard evaluation, and a custom emergency plan before anyone even thinks about stepping foot in that space. It's a principle called prevention through design, where you're building safety in from the very start to get rid of hazards before they even become risks.
All right, let's get practical. Let's walk through the actual actionable steps that have to be taken every single time someone needs to enter a confined space. This four-step process is the absolute core of a safe entry. First, you analyze all the hazards. Then, you authorize the entry with a formal permit. After that, you test the air to make sure it's actually safe to breathe. And finally, you maintain constant communication and monitoring for the entire time someone is inside. Every step, every time.
So, digging into step 1, hazard analysis, the crucial thing here is to think beyond the obvious. What kind of work is being done? Could welding introduce new fumes? And what's happening outside the space? A truck idling nearby could be pumping its exhaust right into your fresh air supply. You have to think about the entire ecosystem of the worksite, not just the little box you're about to enter.
And speaking of specific hazards, this one is vital for LED projects. The screens themselves are made of plastics, right? That means they can be highly flammable. If a fire were to break out, they can release an absolutely nasty cocktail of toxic fumes. We're talking carbon monoxide, cyanide, sulfur dioxide. That is a massive hazard that has to be identified in your analysis.
Okay, next up is the permit to work. Think of this as your formal safety checkpoint. It's a document that proves the hazards have been assessed, the controls are in place, and everyone involved, from the folks going in to the standby person outside, has signed off acknowledging the risks and the procedures. Entry is absolutely forbidden without it.
Now for the hard numbers. Atmospheric testing is completely non-negotiable. Oxygen has to be between 19.5 and 23.5%. Too little, and you suffocate. Too much, and everything becomes a massive fire hazard. Flammable gases or vapors must be less than 5% of their lower explosive limit, or LEL. Any higher, and you're risking a catastrophic explosion. These numbers are the literal gatekeepers between a safe entry and a total disaster.
So, we've done the prep, we've done the tests, but we're not done. The final piece of this puzzle is being prepared for the absolute worst-case scenario, and that means having a rescue-ready mindset.
This quote highlights the single most difficult and yet most important rule in confined space safety. The standby person's job is to be the lifeline, not another victim. Why is this rule so absolute? Because that gut instinct to rush in and help a coworker is incredibly powerful, and that instinct is what has historically turned single accidents into multiple fatalities. They must fight that urge, initiate the planned rescue, and stay out.
Being rescue-ready means having your plan and all your equipment in place before anyone even goes in. We're talking a reliable communication system, retrieval gear like a tripod and winch setup right at the entrance, clear signage to warn everybody else, and physical barriers to stop anyone from just wandering in by accident.
So as we wrap this up, just remember, safety isn't a permit you fill out and forget about. It's a culture. It's a constant state of awareness. The procedures and standards we talked about are the tools, but the real goal is to build an instinct for seeing those invisible dangers before they can ever cause harm. So the question I want to leave you with is this: where are the hidden dangers in your work environment?